Good afternoon, everyone. Thank you for being here today. We are Group 5 and our team members are Abdul Aziz, Brishti Boss, Himapriya, and myself, Barjinder Singh. I will be starting off our presentation today. Let's move on to our first slide and talk about our project. Our project focuses on predicting loan default, a critical task for financial institutions. Accurate predictions can help lenders minimize credit risk, reduce financial losses, and make informed lending decisions. With loan default impacting both economy and individual, this problem is just not technical but highly relevant. The key challenge is identifying borrowers who are likely to default based on various factors such as income, credit scores, loan characteristics, etc. Our goal was to develop a robust machine learning model to predict loan default, evaluate their performance, and gain insights into the factors driving these defaults. In this presentation, we will cover the data we worked with, the pre-processing steps, the models we developed, and the performance. Finally, we will share our key findings and recommendations. So let's dive into our project and moving on to next slide. I will ask Abdul to take over from here and describe our data description.
Good afternoon, everyone. This is Abdul Aziz. So the data set, I'm going to talk about the data set description. So the data set has a total of 255,347 observations, which has details on borrowers and loans, and each row has a unique loan ID associated with the loan. And the data types of the columns are classified into two types. It has numerical data type and a categorical data type. So the outcome of our interest or the target variable is the column name default. It takes in two values, one for yes if the loan was defaulted and 0 for no if it was not defaulted. So the initial EDA analysis are as follows. We have a large number of observations as for loan defaults as we go on increasing the age group, and also we plotted a box plot for income distributions to identify any outliers, and we found out there were no such outliers from the EDA. So I hand over to Preprocessing for explaining other concepts.
Hi, good afternoon. Thank you, Abdul. So from our EDA, we find out the following observations: that there were no missing values or outliers. In the previous slide, you saw that there are a few figures due to the brevity of space, but we did did all the box plots for almost all variables, and we conclude that there were no missing values or outliers. Now, since we are dealing with binary target variable, there can be cases of class imbalance, and we did notice that there was class imbalance. So 88% of the observations of the loan IDs were non-default cases, and 12% of them were default cases. So as a start of the data pre-processing, we start with scaling. We standardized all numerical variables, and then we converted all binary variables to dummy variables, and then we also used one-hot encoding for categorical variables. To handle class imbalance in this data set, we used a couple of methods of handling class imbalance, but we found out that SMOT was the most ideal case, and as it helped in better generalization and AUC improvement. Yeah. For feature engineering, we tried some interaction terms as well to sort of capture the nonlinear effects of income and loan amounts, simply because we thought probably borrowers with high loan and low incomes are more susceptible to default. Large loans create financial stress for low income borrowers. And for the second interaction term, DTI ratio, and credit score, we thought maybe high debt levels weaken the benefit of credit score. So these were the kinds of nuances we wanted to capture through this interaction terms, and we moved on to treating multicollinearity. We removed all those variables with high variance inflation factors, and then we sort of removed those variables. Now I hand over the modeling approach to Hema for her to explain.
Thank you, Prishti. Hey everyone, I am Hema. So coming to modeling approach, we started with logistic regression as a baseline model because it's straightforward and also easy to interpret. It's great for understanding how the features relate to the target variable, but it assumes linear relationships which might not capture the complexity of our data. So in order to handle this, we used random forest, which became our best performing model. Random forest works well because it can model nonlinear relationships and the interactions between features. Plus, it also provides insights into feature importance, which are very useful. So next, also we tried XGBoost, a boosting algorithm that's known for its ability to handle imbalanced data sets like our data set, and also for its robustness. It did a great job of improving prediction accuracy by iteratively correcting errors. So we also tested neural networks for exploring complex nonlinear patterns. While they are powerful, they didn't perform well, likely because of the size of our data set and the need for more tuning. Lastly, we used support vector machines with a radial kernel, which is great for finding nonlinear decision boundaries. However, it required simplifying the dataset due to its high computational cost. So to make sure our models could handle the imbalanced data, defaults being much less common, we applied smart for oversampling, and we split the data into 80% for training and 20% for testing. This ensured that more. Okay, so coming to the results, Random Forest emerged as the top performer with an AUC-ROC of 0.8085 and an accuracy of 80.85%. This shows it was highly effective in distinguishing between defaulters and non-defaulters. It achieved a great balance between sensitivity and specificity. So coming to XGBoost, which is our second best model, with an AUC-ROC of 0.7911 and accuracy of 79.1%, it handled the data complexity well, but slightly lagged behind random forest in balancing errors. So logistic regression as our baseline performed with an AUC-ROC of 0.6948 and an accuracy of 69.48%, showing that linear models struggle with the complexity in our dataset. So coming to both neural networks and SVM demonstrated moderate results, but they were less practical due to high computational costs and tuning requirements. So in conclusion, random forest proved to be the most effective and practical model for this problem. Now I'm handing over to Bristi for continue on discussion.
Thank you, Hema. So from our analysis, we find that some very significant predictors of loan default, first being income, second being credit score, and third being loan amount. So the higher income actually reduces default risk, and a higher credit score also lowers default risk. This is pretty much intuitive, and it actually reflects reality. And we also noticed that loans which are usually very large amount, they increase default likelihood. So people having larger loans usually default. So however, our model is not short of limitations. So the interaction terms have introduced noise in our model, and so we had to ultimately let them go. And our results might not fully reflect the potential of these models due to restricted parameter optimization. So now I hand over this our recommendations, and Abdul will continue from here on.
So we analyzed some potential improvements that could be highlighted. So for deployment, we can use random forest for predicting and also feature ranking. And for future enhancements, we can incorporate cost-sensitive learning models which induce a penalty for a misclassification. We can also explore ensemble models, and we can also fine-tune neural networks for better performance. So I hand over to Parjinder Singh to take over from here.
Thank you, Abdul. Let's move on to conclusion. Although random forest is highly effective, further refinements can enhance its performance. For instance, incorporating cost-sensitive learning can prioritize misdefault, and exploring ensemble models can combine the strength of multiple algorithms. These refinements can help align the model's performance with a specific business objective, ensuring it meets institutional need. In conclusion, machine learning offers tremendous value in loan default prediction, and random forest is our top recommendation for deployment. With ongoing refinements, this solution can become an integral part of risk management strategies. And I would like to thank you, all of you, for your time and attention. Thank you, Professor Nicholson, for your guidance, all our TAs, Sindhuja, Nushra. Thank you very much, and we are happy to answer any question you may have. Thank you.